if you convert it to because I would write 0.001.38, right? Which is kind of the functional test, which is capable of being by that test. So I would write that they don't are not let's do step.
Okay, let's get started. Any questions before we start the lecture today? Okay, just want to make sure that you're actually in the right class. Okay, so this is actually the lecture for Ken 1312, spring semester. Okay, you're in Fleming 160, Tuesday, Thursday, 4 to 5:30 p.m. Okay, make sure you actually in the right lecture place. Okay, can everybody hear me though? I feel like the microphone is actually not very effective. Can you hear me? Okay, good. All right, so I want to start the lectures first by welcome all you come back. Okay, so we lost our first lectures because the cold. Yeah, I hope everybody survived well enough. Okay, it's really freezing. Okay, and I want to introduce myself. I'm Tai-Yen. Okay, so I'm a junior, senior faculties in our department. This is actually my 7th year at UH. I've been teaching this course for, I don't know, 5, 6 times. So relative experience. And how many of you actually trying to Google me before you select this course? Okay, so where did you learn my teaching styles? So many of you learned from readmyprofessor.com, right? It's okay. It's normal. Okay. So I want to actually tell you like who I am and what kind of person I am and what I care, and then what is my perspective toward these courses. Okay. First is that this is like Gen Chem, right? How many of you are chemistry major? Only one. Okay. This has always happened to me. Okay. I rarely get chemistry students. Even though I'm a chemistry professor, it's kind of very strange. Okay. My personal philosophy to this course is that even though I'm a chemistry professor, but I don't think this course is that important to your personal life. Okay, why? My belief is actually depending on what you want to pursue in the future. Okay, the elements you need for your own personal goal will be very different. Okay, and then things most of you is not chemistry major, so I don't expect this one carry too much weight for you. Okay, in your journey. Okay, so it's okay. Okay, it doesn't hurt my feeling that most of my students don't think Gen Chem 2 is actually important. Okay, it is normal. Okay, in fact, none of your courses is less important. None. Okay, because the most important thing is actually you to know what you want to do, right? Then you pick up the most relevant components for your personal dream. Okay, so that's actually the point number one I want to make. Okay, so you cannot say, okay, this is not important to my life, then I don't want to actually learn it. It's a different thing, okay? So the reason I say that is related to point number two. My role for this course, okay? I consider myself as not actually a professor, but I'm trying to become a helper here, okay? I like to help the students who want to help themselves. Is that fair? Okay, so if you reach out to me, ask me questions, I typically respond to all your message within a day. If you don't see me reply within a day, that means I forget about it. Okay, so if that happened to you, don't feel shy, just follow up, okay? And make it very clear that you previously actually sent me this information, but I did not hear back from you. So please reply, okay? Then I will put it on the top list. I'm going to reply you right away. Okay. And the reason I say I want to help the student who like to help themselves is that, okay, if you don't really help yourself, no one can actually help you, right? So I consider and respect every single one of you as adults, okay? When I say adults, I take it actually very seriously, okay? I think you should be responsible for whatever you do, okay? And I know many of you will worry about, okay, do I want to actually come to the lectures in person every day, every time? To me, okay, from the bottom of my heart, my answer to that question is actually I don't really care. I don't, right? Because that whether you want to actually attend these lectures is your own business. Okay, but if you don't come, that just tells me that you don't want to help yourself. Then why bother? Right? Why should I actually help you? Okay, that is actually my philosophy. I want to make it very clear. Okay, if you have any questions, okay, and then if you reach out early, I'll try my best to actually help you understand the material. Okay, and then the course will design in a very interesting way, right? Many of you must actually see my post on Teams, right? Microsoft Teams will be actually the main platforms for us to conduct our lectures. Every single lecture will be recorded. Every single lecture will be posted, okay, on Teams. Okay, so you can actually go back and review all these things. Okay, if that's actually the method that works for you, then it's fine. Okay, just do the way that you like. Okay, but consider carefully about okay what could be actually the best way to get the score that you want for this course. Okay, I think this is a very important concept. Okay, I keep saying the same thing. I don't for 7 years. Okay, it's your future. You are the boss. Okay, I'm a professor, but I'm not the one who is going to stop you. I'm the one here to help you, but only help those kids who want to help themselves. Okay, that's actually my philosophy, and that's actually a second point I want to make. Okay, and I hope that is actually very clear. The third thing I want to make it very clear is that you guys join UH, right? This most of you is actually in the second semester of your freshman year, right? Okay, so UH is a tier 1 university, right? So what does tier 1 mean? Yes, so in United States, we actually categorize the university to different levels, right? Tier 1 means actually we are the university who got the most financial support from the government, okay? Meaning that majority of the professor in this university will be a research-based professor, meaning our main job is actually doing research, right? Teaching is something that we small part of our obligations, okay? So that's why you can see you are going to encounter a lot of professors who doesn't really give a shit about the lectures, right? They're just, okay, I come here, this is a textbook we are going to go through. Okay, just go through the contents inside the textbook. Most actually professors do that. Okay, and there's actually nothing wrong with that because their job is actually not for teaching, it's actually for research, right? We do have some lecture professors and their main job is just teaching. Okay, so it's different. Okay, so you need to be taken into account when you start to complain about the professors. Okay, for me, I'm actually a research professor. Okay, but I do love teaching. Okay, I spend a lot of time, maybe too much time, organize the lecture materials. Okay, and then the only reason I do this is because I want to help those students who want to help them. All right. You can actually know my research a little bit more. You can just go to the chemistry website. Okay, you can see all this information over there. Okay, so I'm not going to talk about this too much. Since we actually lost one lecture, right? That means actually I can actually spend too much time just going through the syllabus with you. Okay, but there are a few things I want to actually point out. Okay, first, this is the Gen Chem 2. The main difference between Gen Chem 1 and Gen Chem 2 is that Gen 2 is a lot more calculation. Okay, so if you know how to do the calculations, that's good. Okay, but it's not enough. You need to do it good. You also need to do it quickly. Okay, so you need to actually become not just good. Okay, you need to become really good to pass these lectures with the grade that you want. Okay, all the lecture will be conducted in person. Okay, even though we record all the lectures, you won't be able to actually attend the lecture through Microsoft Teams. Okay, and that is actually the rules. Okay, I did not design all these rules. Okay, so for the chemistry lectures, especially for Gen 1 and Gen 2, there is actually a group of professors that actually write all these syllabus. Okay, all these syllabus is not written by myself. Okay, so I need to actually follow all these rules written by the syllabus. So every time you're not so sure, okay, your situation, I strongly encourage you to go and check the syllabus. Okay, if it is not described within the syllabus, then we should connect. Okay, but if it is already written on the syllabus, okay, that's how we're going to handle it. Okay, there's actually no exceptions. Okay, all the digital material will be posted on Microsoft Teams. Okay, so make sure that you know how to get to our team site. You know how to actually download all these hangouts on Microsoft Teams. Okay. Textbook, calculators, these minor things I will actually skip. I want to actually focus on this, the gradings. Okay, so after Gen 1, you have very clear idea about how notorious that the grading system is for Gen 1 and Gen 2, right? A lot of homework, very little points. Okay, all the students complaining about it, I know it. Okay, but I'm not a designer, so that's not something that I can change. Okay, the only thing I can do is actually tell you how to actually conquer those things with minimum amount of time. Okay, so I want to actually go to some more relevant informations. Okay, I assume everybody know how to actually reserve your exam spot on CASA, right? So I'm going to skip that. There's actually also some tutorial resources. Okay, you can actually find it on the syllabus. The things that I want to actually say a little bit more is actually related how you actually study this. Okay. The first thing is actually the office hour. Okay, so I know I didn't actually post it on Teams yet. Okay, but I will post it on Teams. Okay. The office hour will be every Friday, 9 to 11 a.m. Okay, you don't need to reserve it, you just come. Okay. If that time window doesn't work for you, it is okay. You just email me. Then we'll figure out the time that work both for you and for me. Then we will connect. Okay. There are a few things that I have no idea, so you don't need to actually email me these type of things. First is actually I have no idea how this course is going to associate with your undergraduate lab. Okay. I don't know how you can actually add yourself to the lab sections. I have no idea, so don't bother to actually email me about that. Okay. I also don't know how you can actually add or drop a course. I have no idea about the tuition and fees. I have no idea about your other classes. Okay, so all the things, okay, like I say, you're adults, right? You should have some idea about what you should do. Okay, and then everybody have a advisor, right? Yeah, so talk to your advisor. Those are the things that you should actually discuss with your advisor. Okay. In the past couple years, sometimes your parents will call me or email me. Okay, and please let your parents know that I am not allowed to discuss your grade with them. It is actually not allowed. Okay, it is just a rule. There's nothing I can do on that. Okay, so please let your parents know if that's expect to happen. Okay. So this is actually more important things that I want you to know. Okay, how to actually get the grade that you want for this course. Okay. The first thing is actually understand the material inside this classroom. Okay, I know how busy you guys, how busy you guys are, right? A lot of courses. Okay, but more importantly, it's actually a lot more activity to participate, to have some fun for your first and second years, right? That is totally normal. Okay. When I was young, when I was actually at your age, okay, I was a crazy player. Not going to lie, okay. So the first year of my grade, I don't know, we have 60 kids in my class. I think my ranking is like 55 out of 60. That's how bad I am, okay. But I still passed my Gen 1 and 2 okay, without much problem. Okay, so why so? First is because my Gen professor is boring. Okay, so I don't know who your Gen 1 professor is. Okay, I guess you can let me know. How many of you feel like your Gen 1 is so interesting and exciting? See, that's how I feel. So it's so you cannot blame me, right? So I just go out, have fun, do a lot like hiking, mountain climbing kind of things. Yeah, so that's what I did when I was young. Okay, yeah. I did not encourage you to do so though. Okay, I just telling you that's what I did. Okay, but it's not actually a very good thing to do because I feel like I played a little bit too hard. Okay, I totally kind of like forget that I need to do my study. Okay, I'm not a very responsible adult. Okay, and the main reason is because I was actually original from Taiwan. Okay, so in the high schools, there's no play at all. Okay, that's actually a very tough situation. You just stay in the library for I don't know how many hours every day, right? So when I become a freshman, I just feel like, oh yeah, life has changed. I want to actually really know a lot of people. I want to actually visit a lot of different places, right? That's why I made a tough decision. Okay, looking back, it's actually pretty stupid. Okay, but that's what it is, right? When I was a junior student, okay, junior and senior year, okay, and I realized that I lost all this so important knowledge back to later. I should actually learn it actually along the way, then everything will be okay. Okay, but I just played too hard in my first year, and then you always need to pay back. Okay, so when I enter my junior and senior years, I go back to my like high school life. I just stay in the library whole day. Yeah, when it open, I enter, leave when it close. Okay, I do it for 2 years. By the time I graduate, I actually ranking 3 out of 60. Yeah, and then I do my master. I become the top one. Okay, so it's actually a long way to turning back. Okay, therefore, I would suggest, okay, all these things, if you encounter a good mentors or good instructors, okay, it helps you greatly. Okay, and then my role, like I said, I want to be a helper here, right? I really suggest that you understand everything we talk about in class. Okay, that's the most efficient way that you can actually get the score that you want for these specific courses. Okay, I've done this experiment for so many times. Okay, and then based on my past teaching evaluations, right, you can see I got pretty good scores on my professors, right? So last year I teach the same courses, just like this one. Okay, I have 300 kids. Okay, at the end of the semester, what do? You do the teaching evaluation, right? I have 300 kids. I got 270 response, which is actually a record high for our department. Okay, no one have ever seen such high feedbacks. Okay, and the main reason is because I feel like at the end of the semester, most of the students realize that the way I teach is effective. Okay, you use the minimum amount of time to get the grade that you want. Okay, so What's the secret about this? It's because we use this flipped class approach. Okay, so I am actually the first one who try to do this approach for the Gen Chem because none of my colleagues believe it will work. None. Okay, when I talk with my colleague, they just, Tai-Yen, this is actually very risky. Okay, very likely that your student will actually fail poorly. Okay, but the things I observed so far is that if the student can trust me and work with me, I think this is actually the most effective way to get the grade that you want. Okay, so inside the class, what we do is we solve tons of questions together. Okay, and it's not just me solving the problems. I randomly pick students come to the stage, work together with me. Okay, I know it sounds scary, very scary to some of you, right? But don't. Okay, I will help you along the way. I won't let you look bad on the stage. Okay, but like I say, I do expect that you watch the video before you come to this classroom. Okay, how many of you have actually watched the video? Good. Okay. Last year, okay, it's actually the first time I started to post my videos on YouTube. Okay, those videos is not random video. Okay, I spent a lot of time trying to condense the material so that you can finish all those things quickly, right? All the videos was actually arranged in a way you can see it's actually a video for week 1, week 2, all the way to week 14. Okay, so I spent a lot of time trying to make it organized for you so that you can just follow along. Okay, the videos I posted, okay, will not cover all the content for your textbook. But if you can just fully understand those content in my video, if you can finish all the questions that I posted on the teams, that's more than enough to get you an A for this course. Okay, I got so many feedbacks from my students, right? So many students say that I don't even read my textbook. I only read Dr. Chen's Hangouts. I got an A. I don't know how to actually say those things to my colleague because it looks like I'm actually discouraged the student to read the textbook. But that's actually what happened. Okay, many of you, I know, I totally understand. You guys are busy. Okay, so if that's what you want to do, that is fine. I mean, again, it's your choice, right? Again, my role is really just a helper. Okay, so you want to actually really know what is actually the way they can get the things that you want in the most efficient way. Okay, I want you to start it efficiently and then play hard when it is necessary. Okay, so that is actually my philosophy. Any questions? Okay, since this is actually a flipped class format, okay, I really need you to watch the videos. Please comment, like, and subscribe. It is very important. Okay, so last year when I started to do this, okay, I tell my students that, okay, I need you guys to subscribe my channel because I want to actually have a second career. Okay, so I'm a tenure professor. Okay, so my main job is still doing research. Research is still my love. Okay, it's actually a lot of fun. I have great undergraduate researcher in my lab as well. I think they're having a good time too. Okay, but I do want to help more students. Okay, and yeah, so please comment, like, and subscribe, and let your friends know that okay, there's actually professors really trying to help undergraduate students to make this course a lot easier. Okay, we have heard this complaint for so many years. Okay, I don't blame the student. Okay, that is actually how they feel, right? It's actually a lot of you need to actually put in a lot of effort to get the score that you want. Okay, I know it's not easy. Okay, so that's why all these things are actually coming from. Okay, I can understand you. Okay, I want to help you. Okay, so that's all the effort I put in. Okay. Here I also list a few things that you need to do. Okay. So on the Hangout, okay, let me show you the Hangout that I'm referring to. You guys have this, right? With all the things actually uploaded on Teams, right? So if you look at those Hangouts, right now I'm going to upload the material for your midterm 1. Okay. Okay. After finishing midterm 1, I upload the midterm 2 and midterm 3, so on and so forth. Okay. In the Hangout, the first page is the summary that I have for this chapter. Okay. Can you believe it? My old students, this is all I read. Okay. Why this is actually, I want to actually show the things to you. One very important things that I think is actually useful, not just for this course, but for your future studies, that you need to learn how to make your own note. Okay? This is an essential skill, no matter what you do in the future. This is an essential skill that you must have. Okay? How can you actually consolidate the knowledge that you from the textbook into some simple language on a single page? Okay? Not 2 pages, not 3 pages, single page. That's the things that you need to learn. Okay. And then you need to learn how to actually organize your ideas, okay, into something that is easily understandable. All these things is actually difficult. Okay, all these things are very important, but none of your professors is going to teach you how to do so. Okay, I like to actually let you know. Okay, this is actually how I condense all the knowledge from your textbook into these simple few lines. And then reading these simple few lines together with the questions associated with it is actually how you can actually get great score for this course. Okay, so in our lectures, we are going to go through the questions, okay, one by one. Okay, I'm going to ask you a lot of questions. Okay, and then the reason I ask you a lot of questions is I want to show you how you should approach the questions. The things I discovered so far is that when students found something is actually difficult, is that they have hard time understand the questions. They don't know what the question is actually asking for, right? So the way I actually handle the question is that I want you to learn how to identify keywords. Okay, keywords is very important. Okay, because from the keywords, you can easily trace back and you can know what specific concept this question trying to actually test you. Okay, so with those things in mind, that means actually once you can identify keywords, then you will know what specific concept is going to asking you, right? So if you look at the note, I wrote this 1, 2, 3, 4, right? Let me highlight this so you can see. You see this? Okay. If you look at the questions, okay, the question is actually not random question. The question is actually all associated with specific concept. Okay, so you're going to see this hangout is universally true for all the hangout I'm going to post. Okay, so that means actually if you read the questions, okay, if you can identify keywords, then you know what specific question, what specific concept the question is going to test you, right? And this allows you to actually quickly know what equation you need to use or what concept you should actually apply. They can actually guarantee you answer the question properly. Okay, so we're going to do a lot of practice to identify the keywords. Okay, then we'll do a lot of calculations together so you know from the very beginning how to read the questions, identify keyword, associate with the key concept, and solve the question step by step. Okay, that will be actually the general approach we're going to use for these courses. Okay, sounds good? Good, okay. And try to respond to my questions as much as you can, okay? Because I really need to see how much you understand. Then I will actually proceed. Second, I'm not a native speaker, okay? Therefore, when I deliver concepts, if I speak too fast, okay, due to my thick accent, you may not actually understand me, okay? All you need to do, just raise your hand and say, Dr. Chen or Tai-Yen, slow down a little bit. I will slow down for you, for sure. Okay, I guarantee I will slow down. Okay, so don't be shy. This is not a time for you to be shy. This is a time for you to grow your knowledge base. Okay, you need to do this for yourself. Okay, being shy doesn't do any good to you. Okay, and I'm a very straightforward professor. Okay, I'm also a very open-minded professor. Okay, I won't be offended no matter what you ask. Okay, I'm fine with all these things. Okay, so let me know whether you can understand the things or not. It's very essential. Okay. All right. Any other questions? If not, shall we start the lectures? Okay. All right, so since we lost one lectures, okay, so some of the concepts I probably won't be able to cover to the level that I like, but hopefully things will actually improve over time. So chapter 10, what is chapter 10? Chapter 10 is all about solution, right? So when you heard the word solution, how to actually make a solution? Yes, you need to have at least something called solvent, something called solute, right? So the solute dissolves in the inside your solvent. Once you form this homogeneous solution, then you have a solution. Okay, so the first thing we want to talk about is actually there are actually many different ways to describe how concentrate the solution is, right? So that's why we actually need to introduce so many different concentration terms. Okay. So when we define concentrations, it's typically have the numerator and the denominator, right? Numerator typically is actually the information related to your solute. Denominator will be the information associated with your solvent or solution. Okay. The most commonly seen concentration is so-called the molarity, right? Okay. So the definition of molarity is actually this. The numerator is actually number of mole of your solute divided by the volume of your solvent, right? So, okay, solute, this will be your solvent, sorry. Okay, so how do you define number of mole? How do you define number of moles? These things, right? The mass of your solute divided by the molecular weight of your solute. Okay. By the way, all the things, every single equations I put on slide number 1 are the things that you can actually memorize. Okay. This is actually the minimum amount of equations that you need to actually install into your CPU. Okay. So that is actually the first concentration term, right? Molarity. What is the second one? Normality, right? So what's the difference between the molarity and the normality? Yeah. So the only differences between this is actually the number of equivalent. Okay, so what is the concept of number of equivalent? So this is typically happen in two types of reactions. First is so-called the oxidative reaction, okay, or redox reaction. Second is actually the acid-base reaction. Okay, for example, what's this? Sulfuric acid. Everybody follow this term? Sulfuric acid, right? That's the chemical formula of sulfuric acid. What's this? Hydrochloride or hydrochloric acid, right? If it's in the aqueous form. Once this is dissolved, the top one give you H plus and then CO minus, right? So what it means is actually if you have one HCl dissociate, it gives you one proton, right? So the number of equivalent is going to equals to okay. However, if you have H2SO4, sulfuric acid, once it dissociate, it produces two protons and then one SO4 2 minus. Okay, so in this case, since you have one H2SO4 to start with, but you produce two equivalent of protons, and therefore the number of equivalent for the second equation is going to equals to 2. Okay, therefore the normality of a 1M H2SO4 will equals to 2N. Okay, so if a 1M H2SO4, this is actually the molarity, right? It's going to be equivalent to 2N H2SO4. Okay, so that is actually a difference between the molarity and the normality. So to calculate the molarity is actually you just use your molarity multiply the number of equivalent. Is that clear? Everybody follow? That corner, do you guys follow? Okay, of course, all the things I say here has been presented in the YouTube video. Okay, so if you haven't had a chance, okay, now it's actually a good time to actually go back and then go through those videos. Okay. What is X? Mole fraction. Okay. So mole fraction was defined as this. Okay. So when we talk about mole fraction, typically we're referring to the mole fraction of your solute inside a solution. Okay, so in that case, what you do is actually you need to calculate the number of mole of your solute on the numerator, right? Divided by the overall mole, okay, the total mole, which is calculated by the combination of your solute and solvent, right? So at the bottom, you will have the Nu plus Nv. Also, I noticed that the screen is actually not very clear somehow. Okay, so if you really need to run in the things, also let me know too. Okay, so similarly, if you want to calculate the mole fraction of your solvent, So right now the solvent is actually your target, right? So on the numerator, you actually put the number of mole of your solvent divided by the total of moles. Okay. So that's actually the mole fraction. The next one is mass percent. Okay. Okay, so base is actually similar to the mole fraction, but right now you actually use just the mass to calculate the ratio. Okay, so the mass percent is typically only referring to your solute. Okay, therefore on your numerator, it will be the mass of your solute, okay, over the total mass of your solution, which is actually the sum of your solute and the solvent. Okay. The very last one. Yes. Okay. The very last one is actually the molality, right? So this one is actually the one that's most special because for the numerator is still the number of mole of your solute, okay? But your denominator is actually the weight of your solvent, not solution, but solvent, okay? So only this one is actually using solvent, okay? All the others is actually using your solution, okay? So this actually somewhat strange, okay? But molality is actually also some commonly used concentration term, okay? And then for the mass of your solvent, it has to be in kilogram. Okay, so all the things is actually something that you need to actually memorize. Okay. With all these things in mind, the other two very important concepts that you should have is that the mass of your solution can be calculated through summing up the mass of your solute and the mass of your solvent. Okay, a very simple concept, but you need to know that. The other thing is actually the density of a solution can be calculated by the mass of your solution divided by the volume of your solution in liters. Okay, so all the things is important equation that you need to memorize. Okay. One very commonly seen questions in your homework is actually the concentration conversion. Okay, so every time when you encounter this concentration conversion question, you first need to know what is actually a known concentration provided, right? So, and it will ask you, okay, what is the corresponding concentration in other concentration units or equals to this concentration? Okay, that is actually the first question type you're going to see for this chapter. Okay, here I actually write a few tips for you to actually get started. Okay, if the known concentration start with the molarity, then you should actually assume the volume of your solution is actually 1 liter. Okay, if you actually start with the molality, assume you have 1 kilogram of solvent. Okay, if you start with the mole fraction, then assume then the total number of mole of your solution is actually 1 mole. If talking about the mass percent, then you assume you have 100 grams of solution. Okay, so why do we need to do this? It looks like, okay, you need to actually memorize all these things, right? But the fact is no. The things I do here is actually just make all your denominator equals to 1. Okay, so that in terms of operation, it will be a lot easier. Okay, so for example, if you have one certain n of solutions, right? You can just make, I guess mole fraction is actually easier to understand. You just make the whole thing equals to 1. Okay. Yeah, we'll go through these examples. Okay. Okay, very soon. Okay, but I want to actually also cover the necessary concept. Okay, because for this week we are supposed to finish the concept 1, 2, 3. Okay, but that's actually pretty much what you're going to encounter for the first concept, conversion of the concentrations. Okay, that is actually one of the most important concepts you'll be tested for your homework and then for your quiz. Okay, now, talking about this, that's actually another thing I want you to know. You have quiz every week, right? You have homework every week. Which one should you do it first? Homework, right? And then for every single homework is actually not timed. That means actually you can take as long time as you want, right? Every week, okay, when you have the access to your homework, open it. So you will see what is actual questions you are going to encounter, okay? I would strongly suggest that you do the homework, okay? When you actually finish less specific sections, make sure you can do it right and do it, okay? After actually get familiar with all the concepts from homework, okay? Make sure you can do it quickly, okay? So then go ahead and do your quiz. Quiz is actually time, right? You have 2 hours to finish a quiz, which contains around 6 to 8 questions. Time is actually so important for these courses because for your midterm, you have 23 questions, right? You only have 75 minutes for your midterm. For your final, you have 31 questions, right? The average time you have for one single question is around 3 minutes, okay? And we all know we got nervous when we do our midterm or final. Therefore, you should push yourself to probably actually finish one question within 2 minutes and 30 seconds, right? That means actually you need to read the questions, quickly associate with the concept. You will know what equation to use, then you do the calculation. There cannot be a delay between all these processes, right? So these actually things that fail students. Okay, many students come to my office and say, I know all these things you talk about. I understand all the concepts. But when I do my midterm 1, I fail poorly. I feel like I don't have enough time, right? Yeah, so it's simply because you did not actually practice this, okay? 4 steps need to be actually done seamlessly, okay? You need to actually read the questions, identify keywords associated with concept, know the equation, solve the problem accordingly. Okay, so you really need to actually practice to that level, okay? When you do your quiz, okay, really time yourself, okay? You really need to actually push to that time limit so that you will feel very comfortable when you do your midterm. And that's how you can get a really good grade for this course. All right? Okay, second thing that's very important for this week is that the solution formation. Okay, we are going to talk about something called the delta H of solution. Okay, so the delta H of solution was composed of 3 terms. The first one is actually called the delta H solute, delta H solvent, and then delta H of mixing. Okay. What is delta H of solute? Okay, so in your homework, or in your quiz, or in your midterms, you're going to see this term called the lattice energy. Okay, write down. delta H of your solute. If you see this keyword, lattice energy, that is your delta H of solute. Okay? So let me remind you again. Tai-Yen doesn't actually say something that's actually unnecessary. You are going to see this keyword over and over again in your quiz, in your midterm, or in your final. Okay, you better know when you see that keyword, write down delta H solute. It's going to be very helpful. Okay. So just in case that you are not very familiar with what I'm talking about. Okay, so what lattice energy means is actually the energy you will need to break apart the salt. Okay, the salt typically forms some specific structure. We call it lattice, right? So to break apart those lattice requires some energy. Therefore, we name those energy as lattice energy. Okay. Delta H solvent meaning. Any questions? Okay, delta H solution. Okay, let's actually know specific term that you can actually associate with it. Okay, so let's actually typically it will just tell you okay the enthalpy of your solvent, right? Delta H is actually enthalpy, right? So typically you will just hear the enthalpy of the solvent. Okay. The third term is the delta H mixing. Okay. Since we're actually talking about aqueous solution, you're going to see these words as well. Okay. Hydration energy. Okay, so if you see this word, hydration energy, it's telling you that it's actually a delta H of mixing. Okay, you can actually associate these terms together. All right. So if your delta H solution is negative, okay, we call this solution, okay, this whole process is exothermic, okay, meaning the delta, meaning actually once you mix your solvent and solute, forming the solution, this process will release heat, okay? So your heat got released, okay? Temperature increase. What does temperature means here? Okay, what is your surrounding? Okay, so this is actually something I feel like students will actually get very confused. Okay, the temperature is actually temperature of the solution. Okay, temperature of the solution. Okay, but why? Why the temperature of the solution will increase? Okay, so I want to actually bring you back to this equation again. We say the delta H solution have three terms, right? Delta H of your solute, delta H of your solvent, and delta H of mixing. The first two terms, delta H of your solute and delta H of your solvent, they are typically positive, okay? Especially the first term. Okay? Positive, what it really means is that in order to actually mix your solvent and solute, first you actually break apart of your solute, right? So when you want to break it apart, you need to actually provide energy to that process, right? That means actually to give the energy to that specific process. Okay, therefore you have this positive side. Okay, you need to actually provide energy to breaking apart all those bonds. Okay, that's why the delta H of your solute or the lattice energy of your solute is typically positive. Okay? Delta H solvent is actually also positive, but much smaller. Okay, it's more or less close to 0. Okay? Delta H hydration or the delta H of mixing is that once you break them apart, now your solvent and solute, they're going to see each other, right? They're going to interact. Once you interact, you actually stabilize. Therefore, you start to release heat. Therefore, the delta H of mixing is actually always negative. Okay? It's a very important concept that you should actually know. With that being said, okay, we say if you have delta H solution is negative, that's actually a very important concept associated with it is that the delta H of mixing is outweighted than your delta H of your solute. Solute plus delta H of your solvent, right? Or you can say the hydration energy outweighs the lattice energy. Okay, so all these things need to be tied together. Okay, when you see the delta H is actually negative, then you should know your delta H of mixing outweighted your delta H of solvent plus solute. You should actually associate with your hydration energy outweighed than your lattice energy. Okay, so why this will lead to actually the increase of temperature? Okay, this is because once you actually start to interact with when your solvent interact with your solute, they become stabilized, right? So they are going to become lower in energy. That means actually they have some excess heat they want to give away. And those heat actually start to heat up your overall solution. Therefore, the solution temperature increase. Okay? Yeah, so if you're not very familiar with the concept, then trying to actually understand and digest these things a little bit. Okay. In contrast, if your delta H of solution is positive, okay, then we call it as endothermic. Okay, so in this case, you have actually need to flip all the things, right? Your delta H lattice is going to be outweigh your delta H of hydration. Yeah, so this is just the opposite. Okay, so let's actually a second type of questions will be tested. Okay, you should know the component of your delta H of solution have 3 terms: delta H solvent, delta H solute, delta H of mixing. Right? That's actually the first things you need to know. And you should also know delta H of your solute is often called lattice energy. Delta H mixing is often called hydration energy, right? When the delta H solution is negative, we know this process is exothermic. The temperature of your solution will increase. You also know that your delta H hydration outweighs the delta H of lattice. Okay, so those are the concepts that after we have this lecture, right, it should be installed into your CPU. All right, cool. Very last one, solubility. Okay, so this is actually another very important concept that you should know for this week. Okay. We will first talk about the liquid solution, meaning your solute and solvent both existing in the liquid form. Okay, and the principle you're going to use is this thing is called a like dissolve like. Okay, specifically, you're going to be tested. Okay, can you actually recognize the things provided is hydrophilic or hydrophobic? Okay, Everybody know what hydrophilic is? What does it mean? Likes water, right? Hydrophobic is actually I hate water, right? So what is the things that will tell you the molecule likes water? Charge is one and polarity is one, right? How do you know it's actually polar or non-polar? Dipole moment. Okay, what is actually, so when you see these equations, right, all you see is what? Atomic symbol, right? What is that the symbol you should actually look for? Okay, it's very simple. OH, NH2. That's it. If you don't see OH, NH2, hydrophobic, right? So if it's actually hydrophilic, you will always see OH or NH2. Okay? If you don't see these two, hydrophobic. Very simple, huh? Okay, so if I give you something, I guess we'll go through some example very soon. Okay. The other type is actually you have solid liquid solution where your solute is actually solid. Okay. It's also very similar, right? Like this of light. We know polar solvent, polar molecules. Water is actually very polar. Okay, so if you look at your solute molecules, if it is polar, then it's high chance can be dissolved inside water solution. Okay. So those are the take-home message you actually have. Okay. Very last things we want to talk about before we actually go into the question is that factors that affect the solubility. In these specific chapters, only two things should be considered. One is temperature. One is pressure. Okay. If you see anything other than these two, those are the items trying to confuse you. So just ignore those things. Okay, so it's very essential that you know what other things will be tested. Okay. Temperature and pressure. The effect of temperature, if you have a solute, is in the solid form. Okay. When the temperature increase, then the solubility will increase. Okay, so any questions on this specific statement? What is solubility? The maximum amount, sorry? Yes, so it is actually the maximum amount of solute that can be dissolved inside your solvent, right? But how do we define dissolve? So I guess everybody did this before, right? You dump your salt into water, you stir it, okay? You dump a little, you stir a little. For some time, then all this white solid disappeared, right? Then we say those salt is actually dissolved into the water, right? So by saying that, what you really say is actually you're actually forming a homogeneous solution. Homogeneous is actually a keyword, okay? Because inside that solution, it is a single phase, right? So homogeneous is important, okay? So the maximum amount of solute that can dissolve inside your solvent at a given temperature to form a homogeneous solution. That's how we define the solubility. Okay, so I hope you can see that. Okay, I did not actually give you just a definition, right? I want to actually see. I want you to define what it is, because only after that you will memorize it. Okay, if just trying to actually repeat the words on the textbook, you will never actually memorize it. Okay, that's actually something that you need to actually practice, because no matter what your major is, that's how you can actually put the knowledge into your mind. Okay, so it's very important skill. Okay, so if today you have gas, it's actually the opposite. Okay, because from your daily life experience, right? When you heat the water into 100 degrees C, from the bubble, right? It just escapes from your solution. Okay, similar concept applied here. Okay, so if you have gas dissolve inside your solution, if you increase the temperature, the solubility of your gas will decrease. Okay, it's actually very simple, very straightforward. Okay, pressure. Pressure is actually another interesting factor. Okay, and this thing is actually only associated with the solubility of the gas. Okay, higher the external pressure, higher the solubility of gas inside your solution. Okay, I assume this is actually a very straightforward concept. Okay, how many of you actually have the what is it called, the soda stream? So you have the machine, right? Everybody know what I'm talking about? Soda stream. It's actually a machine you can actually create this bubbling water, right? So what it does is actually you have a gas tank. You pump the CO2 into your water, then you have this bubbling water, right? So the gas tank is actually high in pressure. Okay, once you actually put these things together, you actually exert a lot of pressures onto your water. They force the CO2 goes into your water solution. Okay, so that's why we say here, if you have high external pressure, the solubility of the gas will increase. All right, so that's all the concept that we need to know for homework this week. Okay, so we're going to go to a few examples. Hopefully we still have some time. Let's start from the easier one first, so that we can make sure that we go through some example that's essential. Okay. Let's go through the question number 7. Which of the following? So this one is actually the one I want to go through. Okay. Which of the following is more soluble in water? Methanol or CCl2H in the liquid form? So what is the keyword? Soluble, right? Soluble in water. Okay. Soluble definitely is actually some keyword that's going to tell you it's associated with your solubility, right? And then what do we learn? We learn about the effect of temperature, effect of pressure, right? We also learn about the solubility. If it's liquid, it's like dissolving light, right? Then if it's actually solid liquid, it's actually the one that's more polar, like to dissolve in water. Okay. Here is actually ask you, okay, which one is actually more soluble in water, right? Those are the keywords, right? So we will know you need to actually find either the solid that is actually very polar, right? Or something similar to water, which is actually hydrophilic, right? How do you know whether your molecule is hydrophilic? You are looking for the OH, NH2, right? That's all. Okay. With that in mind, can actually tell the answer should be methanol, right? It's that simple. Okay, but we are training you to see the keyword, training you to actually associate a keyword to the key concept so that you know what you should be looking for. Okay? Any questions for 7? If not, let's look at 6. A flask containing solid aluminum chloride becomes colder as water is added and the salt dissolves. Is the magnitude of the lattice energy of NH4Cl larger or smaller than the combined hydration energy of the ions? It's a very long questions, right? So what are the keywords here? Colder and very good. I see the word that I really like. Where's that? This one, right? And then, so when you see this keyword, you know it's actually delta H solution, right? There's only less specific section give you all these specific terms. Right. So with that being said, then you know the concept you should really know is just this, right? Delta H solution is equal to delta H solvent plus delta H solute plus delta H of mixing, right? So you know it is become colder means what? Delta H solution is positive or negative? You said the temperature is increase or decrease? It's become colder, right? Colder means actually your temperature decrease, right? That means your delta H solution is positive, right? That means what? Your delta H solute plus your delta H solvent is larger than your delta H of hydrations, right? Everybody follow the concept here? Yeah. So once you know all these things, then we go back to like specific questions. Since it's actually colder, colder means your delta H solution is negative. Oh, sorry, delta H solution is actually positive, right? The temperature is actually decreasing, right? Yeah. And then because you know your delta H of your solution is delta H solute plus delta H solvent plus delta H of mixing, right? And then the first two terms is associated with your lattice energy, right? The second term, so this two term is positive. This term is actually negative, right? Therefore, you know your lattice energy has to be larger than your hydration energy. Therefore, the answer to this question will be larger. Okay? So this is actually how you solve this type of questions. It's actually more concept, right? The key is actually, can you see the keyword? Can you associate with the key concept? Right? Can you actually use the proper equation to make a proper judgment? That's how you solve this. Okay, if you have no things in mind, solving this question is like done, right? But if you don't, you are going to ponder for a long time. Okay, so this is actually how you can actually really address all these questions quickly. All right, so number one is actually all about the concentration conversion. Okay, but before we go into this, I want to remind everybody that on our team side, we also upload a file called chapter 10.1 concentration conversion. It's a PDF, okay? Inside a PDF, I provide a very detailed step-by-step conversion from one concentration to all other concentrations. I will strongly encourage you to take a look, to understand, to digest those steps. Okay, they will actually help you greatly to handle the question 1 to 5. All right. Okay, so I don't know how many questions I can go through today, but we will continue in the next lecture. Okay. First, let's look at question number 1. Calculate the molality of an aqueous solution where its concentration is 8.1 mass percent for the calcium chloride. Okay. The question is actually formulated in a very, at least to me, very strange way. Okay, but keyword here are two different concentrations, right? One is what? One is mass percent, right? One is molality, right? So what you want is actually, I want to convert concentration from mass percent to molality. Okay, these are actually the things that you should actually have in mind, right? So first, the keyword is actually you have two different concentration units. Okay, that is actually the signature that is testing you. Can you do the concentration conversion? Okay, so you want to actually first write out those two specific concentration. Okay, then to figure out, okay, what is actually the known, what is actually the unknown. What is actually the known is actually the mass percent in this case, right? So you know the direction is actually going from here to there, right? Going from your mass percent to the molality, right? Once you actually know this, the next thing you do is actually write down the definition of each concentration. Okay, what is the definition of your mass percent? Right, multiply 100%. Okay, that's actually how you define your mass percent, right? How about your molality? Number of mole of your solute divided by the mass of your solvent in kilogram. Right? These are the things that you need to know. Okay, so the only information that you know from the question is that you know your concentration in mass percent is going to equals to 8.1, right? So you know your mass percent is 8.1%, right? So what do? We assume the total mass is what? 100 gram, right? Therefore, you know the mass of your solute will equals to just 8.1 gram. The mass of your solvent will equals to 100 minus 8.1, which give you 91.9 gram. Right? So you can have that assumption and you can actually get the mass of your solvent, mass of your solute. Any questions so far? Okay, if not, then once you know this, right? But this is actually the things that you want to know. All right? You want to know the ratio between your number of mole of a solute over the mass of solvent in the kilogram. Okay. Do you know the mass of your solvent now? Do you know this? You do, right? This can be easily converted to kilogram by dividing by 1,000, right? So this will be 0.0919 kilogram, right? That's actually the mass of your solvent. Therefore, you have no problem actually getting to know what this is, right? Do you know the number of mole of your solute? You don't know yet, right? But do you know the definition of number of mole of solute? Number of mole of your solute is going to equals to the mass of your solute divided by the molecular weight of your solute, right? Do you know the mass of your solute? You do, right? It's right here, right? 8.1. So you know this is 8.1 gram. What is the molecular weight of your solute? Then you need to know what is actually the solute that you have, right? Calcium chloride. So calcium chloride is CaCl2, right? So I believe that all the chemical formula will be provided in your homework. Okay, so you should be able to actually know what the chemical formula is. Okay. So once you have this, you have your periodic table, right? I assume everybody will be able to calculate your molecular weight. Okay. With that being said, that means actually number of mole of your solute can be actually calculated, right? Since this is actually known, that is actually known, then this can be solved, right? Since you know the number of mole of your solute, the mass of your solvent, then you can calculate what the molality of your solvent, right? Okay, so to make it complete, let me provide some number here. The molecular weight of your CaCl2 is 110.98. Okay, when you do the calculations, you're going to get a value of 0.072986. Okay. Oh, sorry, this is. Oh yeah, this is right. This number of mole of solute 0.072986 mole. Okay. Therefore, you know your molality is going to equals to the number of mole of your solute divided by the mass of your solvent in kilogram. This is going to give you 0.072986 mole divided by 0.0191 kilogram. And you're going to get a final answer of 0.794. Lowercase n. Okay. So this is actually the logic that you should have to solve a question like this. Okay. First is identify the keyword. In these specific questions, you should see two different concentration units. One is molality, the other one is mass percent, right? And then you need to figure out what is actually known, what is actually unknown. Okay, give me 1 more minute, I'll finish, okay? So once you know that, then write down the definition of each concentration. Then starting from the known to figure out, in order to actually solve the unknown, what are the quantities that you should actually figure out. Okay, by doing this, then you can figure out the answer properly. So for density, yes, very good question. Okay, you say, okay, when are we going to use density? Go back and check out the hangout. When you start with the molarity, capital M, to molality, small n, that's where you're going to use your density. Okay, but if there's no more question, that's it for today. Thank you. Yes, give me a second. Yeah, give me a second, okay.